We have Math 158, section 5.2. In this section, we're going to be talking about multiplying matrices, matrix multiplication. We're going to start nice and simple here. This is a difficult process, but doing it this way, step by step, is really going to help a lot. We're going to start with a nice, simple problem and discuss some things about it. For multiplying matrices together, having the same dimensions is not necessary, but there is one thing that needs to be necessary. You have to look at the dimensions. So this is one row and 3 columns. We always name a matrix by the rows and then the columns. So this is a 1 row, 3 column. We call this a 1 by 3 matrix. This matrix is 3 rows, 1 column. So it's going to be a 3 by 1 matrix. In order to multiply matrices together, the middle terms, or not the terms, the middle dimensions have to be the same. So the first matrices columns have to be equal to the second matrices rows. So these middle numbers have to be the same. The result of this matrix multiplication is going to be what the outside numbers are. So the result of this matrix is going to be a 1 by 1 matrix. It's only going to be one number, a 1 by 1. So let's go through the process of this. What you have to do is you are taking every row of the first matrix and you're multiplying it by every column. Right? Let's go with the flow of it. Doing an example is going to help you better understand what I'm talking about. All right, so we go piece by piece. So the first row, first column. So we do 2 times 2. And we move on to the next. 4 times 10. So plus 4 times 10. And then we move on to the last entry in the row in the column. We have 1 times -1. So plus 1 times -1. So we have the first row times the first column. That is going to be row 1, column 1 entry of our 1 by 1 matrix. Right? That doesn't make much sense in this situation, but we're going to talk about that when we get to more complex situations like that. So we simplify this down. 2 times 2 is 4. 4 times 10 is 40. Then 1 times -1 is -1. 4 plus 40 minus 1 is 43. Our 1 by 1 matrix is 43. Now we're going to go on to a slightly more complicated problem. Our next problem is we have 2 matrices that are both 2 by 2. So we're going to go through that process again. This matrix, the first matrix, is a 2 by 2. The second matrix is a 2 by 2. So as I said last time, in order to multiply matrices together, their middle dimensions have to be the same. So the columns of the first matrix have to be equal to the rows of the second matrix. The resulting matrix is going to form a 2 by 2. So that's the outside dimensions tell you the rows and columns of your resulting matrix. All right, now let's go through the process of creating a 2 by 2 matrix. When we do this, we are looking at the first entry being from row 1 times column 1. So this is going to be row 1, column 1. This next entry is going to be row 1 times column 2. This next is going to be row 2 times column 1. And then row 2 times column 2. That's what we have to do in order to form this 2 by 2 matrix of our answers. So we need to multiply the first row by the first column. So that's going to be 1 times 3 plus -1 times 5. So 1 times 3 plus -1 times 5. That's going to be the result of this little expression here, is going to be that first entry here. Right, I like to go through and do all of this before calculating this out. I go through and do all 4 of these operations, and then I simplify. Right, if you want to simplify all at once, go for it. Next, no particular order here, I'm going to stick with the first row. I'm going to multiply it by the second column. So I'm going to have this entry right here, row 1 times column 2. So this is going to be 1 times 0 plus -1 times -1. Now I have to deal with both of the second row. So row 2 times column 1 would be 0 times 3 plus 2 times 5. Notice what I like to check here that I'm doing it okay is that the numbers in the parentheses vertically are the same. So over here, we're going to have 0 times 0, 0 times 0, row 2 times column 2, plus 2 times -1. Now, that would be our resulting matrix, but I have to simplify that. So I'm going to do the multiplication first. So 1 times 3 is 3, -1 times 5 is -5. 0 times 3, 0, 2 times 5 is 10. So this is going to be 0 plus 10. Then we have 0 plus 1, -1 times -1 is 1. And then we have 0 minus 2. So our final answer for our matrix, 3 minus 5 is -2. 0 plus 10 is 10. 0 plus 1 is 1. 0 minus 2 is -2. Our final answer for multiplying this 2 by 2 times a 2 by 2 is a 2 by 2 matrix. Now we all know that multiplying regular numbers together is something called commutative, which means it's the same no matter what order we do it in. So 2 times 3 is the same thing as 3 times 2. Right? We get the same, it doesn't matter what order we multiply in. Let's see if the same thing holds true with matrices. So all I did, if you look back at the last problem in your notes, is I took the 2 matrices and I just am multiplying them in a different order now. I switched the first with the second with the first, just flip-flopped them. Let's see if we get the same answer, and also we can practice. You can pause the video right now and practice multiplying this out before you see the answer. But I'm also going to just practice through on doing it again. A little bit quicker this time, maybe. All right, so first row times first column would be 3 times 1 plus 0 times 0. First row times second column would be 3 times -1 plus 0 times 2. Second row times first column would be 5 times 1 plus -1 times 0. And the second row times second column would be 5 times -1 plus -1 times 2. We multiply it all out. So that's going to be 3 plus 0, 5 plus 0, -3 plus 0, and -5 minus 2. So our final answer is going to be 3, 5, -3, and -7. Now, If you look back in your notes, that is not the same answer that we got by the first multiplication problem by doing this times this. So A times B, matrix A times B, is not the same thing as multiplying B times A. They are not commutative. So multiplication of matrices is not commutative. I believe I spelled that right. Commutative, yes. All right. So it does matter the order you're multiplying them in. You have to be aware of that. So now we did a 2 by 2 times a 2 by 2. We actually did that twice. We have to go through and take it another step. So our next problem, what I'm doing is I'm giving you two matrices. I'm telling you that this is matrix A, this is matrix B. We're going to start off nice and simple. And I'm just looking to multiply A times B. Now we have to first see if we can do it. Do the dimensions line up? All right, matrix A has 2 rows, 2 columns. It is a 2 by 2 matrix. Matrix B has 3 rows, 2 columns. So matrix B is a 3 times 2. In order for our matrices to be able to be multiplied together, they have to have the same inside dimensions. The columns of the first matrix do not match the rows of the second matrix. So we simply say that it cannot be multiplied. I'm sure there's some kind of technical term for it. If you look up on the back of the book, there might be some kind of explanation or a symbol. I just say it cannot be multiplied. Our dimensions do not allow for it. But what if I asked you to multiply B times A? Flip-flop them. Well, matrix B, we found out, is a 3 by 2, and matrix A is a 2 by 2. So the inside dimensions here do line up. The resulting matrix is going to be a 3 by 2. So when we multiply these two together, B times A, we're able to get an answer, but A times B, we can't be because those middle dimensions don't line up, but this one does. So let's go ahead and multiply them. So I'm just going to rewrite. I'm going to start with B. 3, 0, -1, 4, 2, 1. I hope I have enough room to show this to you. 1, 2, 0, -1. Okay, so our resulting matrix is going to be a 3 by 2. We're going to have 3 rows, 2 columns. That is formed by taking the first row, multiplying it by the first column. That is going to be entry row 1, column 1 of our resulting matrix. So I'm going to kind of start up here. If you follow along, I'm going to have 3 times 1 plus 0 times 0. And that is row 1 times column 1. Now we're going to do row 1 times column 2. So that is row 1, column 2 entry. So that's going to be 3 times 2 plus 0 times -1. Now we move on to our second row, our middle row over here. So row 2 times column 1 is going to be -1 times 1 plus 4 times 0. And then row 2 times column 2 is -1 times 2 plus 4 times -1. Move on to our third row. That's going to be 2 times 1 plus 1 times 0. And then our third row times our second column would be 2 times 2 plus 1 times -1. When doing this, something that really helps me out, so I'm not looking back and forth, as I mentioned before, those numbers in my parentheses are going to be the same vertically. The numbers out in front of the parentheses are going to be the same horizontally. I kind of keep that in mind to make sure that I'm not messing up. I kind of look at the patterns over here. So this is going to be how I get my 3 rows and 2 columns of my new matrix. So now I start to multiply these together. So 3 times 1 is 3. 0 times 0 is 0. -1 times 1 is -1. Plus 4 times 0 is 0. 2 times 1 is 2. 1 times 0 is 0. 3 times 2 is 6. Plus 0 times -1 is 0. -1 times 2 is -2. Plus 4 times -1 is -4. 2 times 2 is 4. 1 times -1 is -1. My last result is just going to be adding those numbers together. 3 plus 0 is 3. -1 plus 0, -1. 2 plus 0, 2. 6 plus 0, 6. -2 minus 4, -6. 4 minus 1 is 3. So we have a 3 by 2, so B times A, so 3 by 2 times a 2 by 2. So we have a 3 by 2 times a 2 by 2 results in a 3 by 2. When we multiply row by column, then row by column, row by column, row by column. All right? We are going to go one step further with this, and we're going to add in a problem that has a dimension of 4. This is going to be the last problem that we're going to do for 5-2 in matrix multiplication. In this particular video, I know there's more in 5-2 if you take a look through it, but I'm going to save those particular topics like identity matrices and things like that. I'm going to save those for to incorporate with 5.3 because they make a lot more sense to be there. So if you get a little confused of why I didn't do all of 5.2, I'm saving the 5.2 stuff for 5.3 video. So it's going to be a miracle if I can fit it on this small whiteboard, but I'm going to do my best. Hopefully I don't have to scrunch it in. So let's see if I can actually multiply these together. So we go through our first matrix is a 2-row, 1, 2, 3, 4 columns. So it is a 2 by 4. Right? I have a little bit of space here, so I'm going to do it in here. Our second matrix has 4 rows. That's good. I like that. 4 rows and 3 columns. So it's a 4 by 3. So can I multiply these together? Yes, because those inside dimensions are the same. If I switch these, would I be able to multiply them together? No, because they wouldn't match up. Our inside dimensions wouldn't match up. So let's go for it. So the result of this is going to be a 2 by 3 matrix. All right, so same process. Now I'm just going to have 4 things to multiply together. All right, so I have 4 entries in a row and 4 entries in a column. So I have a lot more multiplication going on. So we're going to just take it a single step at a time. Ready? We have 2 times 1. 2 times 1 plus 0 times 1 plus -1 times 0 plus 3 times -2. Now, what I like to do is I like to stay on the first row and go to the next column. All right, starting to kind of, I gotta scrunch it together a little more. All right, so we have 2 times 1. I might do myself a favor and kind of put in some guiding lines here so you don't get a little confused on what's going on. So we have 2 times 1 plus 0 times 0 plus -1 times 5 plus 3 times 8. Okay. My next row times my last column. So row 1 times column 3 is going to be the entry for row 1, column 3. See how that works? So this is going to be 2 times -8 plus 0 times 0 plus -1 times 2 plus 3 times -1. Ooh, just fit that in. All right, now we're moving on to our second row, first column. So that would be 1 times, now I like to use these. I know they're going to be the same for this column. So this is 1 times 1 plus -1 times 1 plus 2 times 0 plus -2 times -2. Right? Our next second row by second column is going to be 1 times 1 plus -1 times 0 plus 2 times 5 plus -2 times 8. Our last entry is going to be row 2 times column 3. So that's going to be 1 times -8 plus -1 times 0 plus 2 times 2 plus -2 times -1. Oh no. Ooh. All right. So I have, in all of this, I have my 2 rows, 3 columns of my resulting matrix. What I have to do is I just have to simplify that together. I apologize for this being maybe a little hard to read. Hopefully you're following along, and hopefully you can zoom in. I wonder if I can make it closer. I don't know. All right, so let's figure this all out now. We've got to do a bunch of multiplication. So 2 times 1, 2. 0 plus 1, 0. -1 times 0, 0. 3 times -2, -6. 1 times 1, 1. -1 times 1, -1. 2 times 0, 0. -2 times -2 is +4. Move on to our next column. We have 2 plus 0 minus 5 plus 24. So 2 plus 0 minus 5 plus 24. So 1 times 1 is 1, plus 0, plus 10, minus 16. So now we move on to our last column. Negative 16 plus 0, minus 2, minus 3. Negative 8 plus 0, plus 4, plus 2. Now we just have to simplify those together. So 2 minus 6 is negative 4. 1 minus 1 is 0, plus 0 plus 4 is 4. 2 plus 0 is 2, minus 4 is negative 3, plus 21, or plus 24 is 21. And 1 plus 10 is 11. 11 minus 16 is negative 5. Negative 16 minus 2 minus 3 is negative 21. And negative 8 plus 4 plus 6 is negative 2. Okay, so we just multiplied a 2 by 4 times a 4 by 3 and got a 2 by 3 matrix out of it. It was a lot of work. This is a big dimension, that 4 adds some extra work to it, but it's good to see that process of what I did again. All right. Once again, keep safe, stay healthy. I'll see you on Wednesday for the web chat. I'll answer all your questions from chapter 4 and on to chapter 5. All right. Have a good one.